Okay, students, hope all of you been online. So we need to study a bit more about this dimension formula. Last class we only studied about this dimension formula, but that not enough. We need to study much more detail about this dimension formula. It have some applications. So what are the application of the dimension formula? Like that, a few more things we need to study. So actually we are continuing. Okay, we are continuing yesterday's class. Few more continuation of yesterday's class. Few more topics are there. So what is dimension formula? Okay, we can start from there. See exactly what the dimension formula means. It's a physical formula. It's a dimension formula is a physical quantity. It's an expression showing the dimensions of the base quantities. Okay, so answer for what is dimension formula? Okay, one more time. What is dimension formula? That is answer is that dimension formula is a physical quantity. Dimension formula is a physical quantity in an expression. Dimension formula is a physical quantity in an expression showing the dimensions of the base quantities. Dimensions of the base quantities. Dimensions of the base quantities. Dimensions of the base quantity. Okay, so what is this meaning? Actually, dimension formula is giving. We are using so many units. Okay, but basically in basic units, how much dimension is there? How much depends on time? How much depends on length? How much depends on mass? So basically, how much is depending? So that's showing by this term dimensional formula. So we can see first of all, last class we already studied what are the how to write the dimension formula. Today we are going to study about uses of dimensional equations. Uses of dimensional equations. Today we are going to study about this uses of dimensional equations. Uses of dimensional equations. Ready? So first use to check the correctness of an equation. To check the correctness of an equation. To check the correctness of an equation. First use. Okay, students. We are not these videos we are not uploading to YouTube or somewhere. If you want, if you miss, okay, try to attend the class as live. Somehow, if you miss the class, you can contact the school or no, you miss, you will get the link. You will get privately, we will send that video. Okay, we are not uploading to anywhere else. We are not uploading to YouTube or somewhere. If you want, try to attend live class. Somehow, any power supply or whatever may be, any issues are there, we will collect it privately from school or from SNOIMS. Okay, so we can continue. So it's not only for this class, for all class, ISC and ISC2, IC1 and ISC2 are not uploading to YouTube. So only for lower classes. Okay, get back. So we are going to study about this uses of dimensional formula. First we are starting with to check the correctness of an equation. First application is to check the correctness of an equation. To check the correctness of an equation. What's the meaning? To check the correctness of an equation. Just imagine if we got one equation. By using dimension formula, we can check if that equation is correct or not. By using dimension formula, we can check that equation is correct or not. In other words, every equation should be dimensionally correct. Then only the equation is valid. Every equation should be dimensionally correct. Clear? So we can start how to check the correctness of an equation. I will start with a simple equation, then I will give you workers, then you will do complicated equations. Okay, I will show you just one example how to check correctness of an equation. We can take first equation of motion. Who's there? Who's online? Stephen, are you there? Stephen? Just talk, Stephen. Stephen? Hello? Stephen? Yeah. Have you studied all the equations you have studied this year? Yes. Stephen, what is the first equation of motion? First equation of motion. V equal to U plus D. Exactly. So, Stephen, we are going to check whether the equation is correct or not. Ready? So, we can start. Okay. Okay. Ashish, ready? Ashish?
Yes.
Okay. We are going to check the first equation of motion is correct or not. Ready?
Yes.
Okay, don't cut your audio. Listen here. So, we can start with this equation. V equal to U plus AD. So, first equation V equal to U plus AD. Ready? Ashish?
Yes.
Okay, Ashish, do you know what is the unit of V? What is V?
Well, define as close.
Find a velocity. Are you sure?
Yes.
Confident?
Yes. Yes.
Yeah. So, what is unit? SI unit. Meter per second. What is VU? Yeah, what is unit? Meter per second. Then, what is A? That is the acceleration. Unit? Meter per second square. Then, T? Unit? Seconds. So, students, your first job is, you already, okay, all of you have this equation. Your first job is convert each of them into physical dimension formula. Okay, all of you. V, just write as V here, and write this dimension formula here. This is M, L, T. M raised to 0, L raised to 1, T raised to 1. Like that, convert all the quantities. Then write U, then A, then T. So convert all the terms of the equation into dimension formula. Start fast. No need to refer the previous page. Just convert all the equation to dimension formula. Hail.
Yes, sir.
Ready? Converted. Complete fast.
Yes.
You are ready? Hail. Okay, Hail. Just read your answers. What about you? What is the dimension formula you obtained?
0.
Yeah, M raised to 0, L raised to
1.
1, then T raised to?
Negative.
Okay. Then what about A?
M raised to 0.
M raised to 0,
L raised to 1.
L raised to 1,
T raised to negative 2.
negative 2. Then one more time, that is T. Yeah.
M raised to 0.
M raised to 0,
L raised to 0.
L raised to 0,
T raised to 1.
T raised to 1. Okay. Next, Devpriya. Have you got this all this answer correctly? Sure. Devpriya, what is the dimension formula of force? Let's find out without changing page. M1 L0, then L1, fix something. What? M raised to? M raised to 1, okay. L raised to 1, T raised to? Okay, fine. Okay, students, so hope all of you, your first step is over. Just find the dimension formula of each day. Your next step, instead of each day, just substitute the arrow dimension formula. Instead of V, put the dimension formula of V. Instead of U, put the dimension formula of U. Like that, instead of each day, put the dimension formulas. Instead of each time, put their own dimension formula. Okay, instead of A, put the dimension formula of A. Instead of T, put the dimension formula of T. Like that, each time replaced by its own dimension formula on the basic equation. Agil?
Yes, sir.
Ready?
Yeah.
Completed? Have you completed a step?
Yeah.
Yeah, okay. Just say what you obtained. Just the equation. Agil?
M0 L1 T minus
L1
L1
T raised
T
to?
minus
Okay. N
is
equal to
M raised to 0
M raised to 0, L raised to
L1
1, T raised to?
and L1
Okay, next. Continue. Plus
M raised to 0
M raised to 0, L raised to? L raised to 1,
T raised to -2
T raised to minus 2. Then, completed? Is it completed? Into
M raised to 0
M raised to 0, L raised to 0,
T raised to 1.
T raised to 1. Okay, fine. Okay, so students, we have till here. Now we have a job, we need to complete it, we need to solve it. See, if you want to solve dimension formula, the rules are different. Want to solve dimension formula, here the rules are different compared to normal calculation. Here rules are different. Cleanse. Cleanse, are you there? Cleanse, are you there? Just talk. Yeah, okay, fine. Cleanse. Ready? Yeah, you are going to solve the next step. Okay, cleanse. Just ask one doubt. What is A square? A into A? A square. A by A. A plus A. A minus 2A. A minus 2A. Minus A. Okay, correct. So, you know the basics of mathematics. Cleanse? Yeah, okay. So, students, I am going to erase this side. Here I am going to write few equations. Okay. Few equations. See, U into U Friends, what's the answer? U and U. U square. Then U plus U. 2U. Is it correct? Cleans? 2U. Okay, let's see. What is U minus U? Cleans? U minus U? 0. U by U. What is your response? Cleans? 1. Twins, how many wrong answers are there in the board? Twins? Okay. Then? Okay. But cleans, all these are correct. None of them are wrong. Do you agree with that? Cleans? Do you agree with that? So all are correct. Okay, then? So you're saying that a few of them are wrong. Am I right? Cleans? Cleans? Are you there, Cleans? Cleans? Yeah. So you're saying that few of some answers are wrong. Am I right? Yeah. Cleans should say with confidence. Are you sure? Yeah, okay. So we can discuss with other students. So I need someone else. Okay. Okay. Jesriya. Yeah, so Jesriya, what's your opinion? How many of the equations which are written as correct and how many of them are wrong? See, this first one is correct, then?
Second one 2U.
Okay.
Third one 2U.
Okay.
Fourth one 1.
1. But Jesriya, I'm saying that all these four of them are correct. Okay, do you agree that?
Yeah.
No. But I'm saying again, all of these four of them are correct. Can you explain how's being correct?
I don't know.
You don't know. See, we can.
It's wrong.
Okay, so according to you, 3 of them are wrong and 1 is correct.
Yes.
Okay. So students, actually, all these 4 of them are correct. How's being possible is that here we don't calculate any alphabets or something. It's a calculation for units. It's a calculation for units. Any unit into same unit. Meter into meter, you will obtain meter square. Meter plus meter, you will obtain meter only. See, think in that way. Meter by meter should become unitless. Devika? Devika?
Yes, sir.
Devika, 10 meter plus 2 meter.
10 meter plus
2 meter. 10 meter plus 2 meter. Fast?
12 meter.
12 meter. So what happened to unit?
Remains the same.
Is it 12 meter or 2 meter?
No. 12
No,
meter.
12 meter only. So what happened to unit? Unit? does not change. So that's thing we obtain. We can see here. It's not the normal way of adding multiplication, subtraction, or division. It is a way you can add units. When you multiply through units, it will become square. Meter into meter, meter square. If you add 2 units, you will obtain same unit only. If you subtract 2 units, you will obtain same unit. But here one condition is there. These 2 units not become equal. 5 units means we can ask to somebody else. Ivan.
Yes, sir.
Ivan.
Yes, sir.
Yeah. So 10 kilogram minus 3 kilogram.
7 kilogram.
Kilogram only. Sure.
Yes.
So 10 kilogram minus 10 kilogram.
0.
0. Is there any kilogram? Is there?
No.
No. So 0 kilogram. 0 or 0 kilogram. What's your opinion? Even
0.
0. So no kilogram. Just 0 only. Even
Yes.
10 kilogram minus 10 kilogram. I need an answer. Just 0 only?
No, 0 kilogram.
0 kilogram. Are you sure?
Yes.
Yes. I will ask your opinion to one more students. Okay. Esther.
Yes, sir.
Esther, what's your opinion? 10 kilogram minus 10 kilogram.
0.
0 only. 0 or 0 kilogram?
0 only.
0 only. So Esther is correct. See, here one condition is if u is not equal to 0, this resultant unit means here the magnitude is not equal to 0, then only when we subtract between 2 units, so obtain same unit. Okay. Then if you divide 2 units, what happens? Meter by meter, it's become unitless. Meter square by meter square again become unitless. So students, just note the laws for units. Just note the laws for units. How to add, subtract, divide and multiply units. It's not the normal way which are you used to be. So it will be difference is there. Another way you have to adapt this. So these are the methods. The method when you are dealing with the units. Follow this pattern. Okay. So students, now just complete this right side. So complete right side. Just try. Complete this right side and obtain I just want a final equation. All of you, complete. Okay, John Lee. John Lee?
Yes, sir.
Completed?
No.
No. Complete fast. All of you complete fast. See, about physics, it's not a book to keep like a record book. Okay, you will make mistakes, you will correct it, you can cut it, no problem. Okay, so you just try, that's enough. There will be mistakes, cut it, start again. That's a method. Don't feel like that you only write correct thing and don't cut in your book like that. Don't give physics book like that. It's a training book, feel like that. Okay, John Lee? John Lee?
Sir.
Ready? Completed? Okay. What's the final answer when you solve this 3? What's the final answer to obtain? Johnny. Okay, Johnny, just type your final answer. Johnny, just type your final answer. Johnny, just type your final answer. Mahadev, don't go anywhere. Mahadev, are you there? Mahadev, don't open any other windows. Listen here. Listen here. Okay. So students, we are going to solve this thing. So we can start. See. Okay. So students, we can solve it. So just follow the law. See, all of you try to solve multiplication or division first. Okay. Don't touch plus or minus. First, all of you go to multiplication or division. So we can solve this plus later. So m raised to 0, l raised to 1, t raised to minus 1. Then when we are adding here, m raised to 0, m raised to 0. What do we obtain? M raised to 0. L raised to 1, L raised to 0. So just add the power, that's all. What happened? L raised to 1. T raised to, see just here, look here, minus 2 plus 1. So what happened? T raised to minus 1. As you know, when 2 units added, what happened? Same units added, same unit only we obtain. So our answer is C, m raised to 0, L raised to 1, T raised to minus 1 equal to m raised to 0, L raised to 1, T raised to minus 1. So we obtain both sides of the equation with the same dimensional formula. Both sides we obtain same dimensional formula. It means that equation is dimensionally correct. So we obtain as this equation is dimensionally correct. Okay. So students, time for a doubt. Any doubts regarding this first method? First use. Any doubt in any step you can ask. Clear it now. Any doubt in any step, clear it now. Anybody? Any doubt in any step, clear it now. Devika, clear?
Yes, sir.
Mahadev? Mahadev?
Yes, sir.
Clear?
Yes, sir.
So are you confident you can solve any dimension formula? Any equation with the dimension check you can, are you confident about any equation can be checked dimensionally correct or not? Do you able to do that? Mahadev? Okay. So students, I'm going to erase the board. Okay, say students, just check one more dimension formula I am giving. So I am giving one more equation. This time you are going to solve it. So this equation is S equal to ut plus half at square. So this is equation. Check this equation dimensionally correct or not. Check this equation dimensionally correct or not. Complete fast. See one more thing before continuing. See if there are any numbers are there in between in equation, if there are any numbers are there like this, just ignore the number. No need to consider. Just proceed. The number is not there. If there are any numbers are there, just proceed. The number is not there. Okay, complete those two. Okay, Stephen. Stephen? Stephen? Stephen, are you there?
Yes.
Yeah, have you completed? No. Then? Yeah, what's the dimension formula of S? What is S? Stephen, what's the first step? Stephen, what is the first step? All dimension formula. Okay, what is S? Distance. Okay, what's the dimension formula of S? M. M raised to 0.
L raised to 1.
M raised to 0, L raised to 1, T raised to 0. Okay, what is next term? U. What's the dimension formula of U?
M raised to 0.
M raised to 0.
L raised to 1. T raised to -u.
Okay. Then T. Yeah. M raised to
0.
L raised to
M raised to 0.
L.
L raised to 0.
Okay. T raised to
T raised to 1.
okay. Then what about 2? 1 by 2.
That we need not consider.
Okay, just ignore 1 by 2. Then what is the acceleration?
M raised to 0.
M raised to 0,
L raised to 1.
L raised to 1,
3.
T raised to
-2.
-2. Then T only, see already we written the T, so no need to repeat again. So what is the next step?
Next we are going together.
Right to?
Right hand side. Everything together.
Okay. So instead of S we can write M raised to 0, L raised to 1, T raised to 0 equal to, instead of U,
M raised to 0.
M raised to 0, L raised to 1, T raised to -1. Then T is M raised to 0, L raised to 0, T raised to 1. Okay, so then plus. Okay, I'm writing. See, students, I'm continuing here. So what is A? M raised to 0, L raised to, see this 1 by 2, these numbers are there, no need to consider, just ignore it. That's enough. So M raised to 0, L raised to 1, T raised to -2. Then, yeah, T also there again. M raised to 0, L raised to 0, T raised to 1, all square. So which one we need to solve first? Addition or subtraction? Stephen? 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 Yes, which one we need to solve first? Just talk. Multiplication. Okay, so before multiplication you should solve square. Okay, follow this order: squaring, division, multiplication. Okay, so powers are there, solve the powers first, then division, then multiplication. So any power terms are there?
Yes.
Yeah, okay, so we can solve that power term first. So M raised to 0, L raised to 1, T raised to -1, M raised to 0, L raised to 0, T raised to 1, plus M raised to 0, L raised to 1, T raised to -2. So Stephen, what do you obtain here? M raised to? Stephen? What do you obtain here?
M raised to 0.
M raised to 0, L raised to
0.
0, T raised to 2. Sure? Okay. So 1. How you obtain 1? 2. Fixed. How you obtain 2? 1 plus 1 or 1 plus 2 or 1 into 2 or which calculation you have made? 1 into 2. Okay, correct. Now we can go to next one. Tiffin?
Yes.
Which one? Which type of calculation next? Next priority? Yeah, now we have multiplication. So we can multiply these two. So what do you obtain? M raised to 0, L raised to 0, fixed. See, if you want to multiply powers, just add them. Okay, Stephen? If you want to multiply powers, just add the power. So what's the result here? L raised to 1, correct. Then T raised to. How to solve this one? Minus 1 plus 1. So what is the result? 0. Okay, students, this for common I am saying to all. When we want to multiply the powers, just add them. Next, plus. Here, M raised to 7, continue. Fast.
M raised to 0.
0, L raised to
1.
1, T raised to minus 2 plus 2, 0. So when we add these two, what will obtain? See, here it is M raised to 0, L raised to 1, T raised to 0 equal to, Stephen?
M raised to 0.
M raised to 0, L raised to 1, T raised to 0. So we have proved that LHS equal to RHS. So equation is dimensionally Stephen? Now we proved that equation is dimensionally correct. Okay. Now we have proved that this equation is dimensionally correct. Okay. Any doubts? Anybody? If you don't have any doubts, solve the next equation. V square equal to U square raised to As. If you don't have any doubts, if you have any doubt, you can ask. Else, you can start new equation. V square equal to U square plus 2As. Solve. And prove that equation is dimensionally correct. V square equal to U square plus 2As. Prove that equation is dimensionally correct. Okay, hope all of you completed. Mahadev, completed? Mahadev, completed?
Yes, sir. Yes, sir.
Does the equation is dimensionally correct or not?
Yes, it's dimensionally
So it's dimensionally correct. Okay. Okay, Sebastian, are you there? Sebastian, what do you obtain? Is dimensionally correct or not?
Yes.
Dimensionally correct. Okay, we can start dimension. The Sebastian, we can solve this again together. Ready? Okay, so we can start first. We have the equation B square equal to U square plus 2As. So Sebastian, what's the first step? Sebastian, dimension formula of each. Yeah, each day. So we can start. Yeah, give the dimension formula first. Sebastian, just say M raised to 0, L raised to 0, L raised to Sebastian 1, T raised to T raised to Sebastian? T raised to?
-1.
Okay. Then next U. Very fast. M raised to? Fast. M raised to?
M raised to 0.
0. L raised to? 0.
Raised to 1.
T raised to?
T raised to -1.
-1. Sebastian, what is U? Initial velocity. What is the unit of initial velocity?
Meter per second.
Where is the meter here on the diameter formula? Where is the meter?
N raised to 1.
Where? Here.
M raised to 0 and 1.
Okay. Need any imposition, Sebastian? Any impositions needed?
1.
Needed. Okay, Sebastian, next one. E for A.
M raised to 0.
M raised to 0.
L raised to 1.
L raised to 1.
A raised to -2.
E raised to minus
2.
2. Then one more time.
Displacement.
M raised to
M raised to 0.
0.
L raised to 1.
1.
A raised to 0.
0. Okay. So next, Nivedita.
Then
Nivedita. No, Sebastian is enough. You can mute your mic. Nivedita.
Yes, sir.
Yes. So have you completed? Yeah. What's the final answer you obtain? Say Rameshte correct or not?
Yes.
Okay, we can continue. What's the next step, Nivedita? Next step. Yeah, what is next step? What?
Right side.
Okay. So just substitute for each day. Okay. So yeah, just say Nivedita fast. Continue, Nivedita.
M0.
M0, M raised to 0. L raised to? L raised to?
L raised 1.
1. Then
Raised to 1.
T raised to -1. That's enough. Square
So it's
plus.
yes.
What about 2?
M0.
No, what about 2? What about 2? What to do with it? What?
We need that.
Okay. So next one. Fast. Nivedita. M0. Okay, L raised to 1. T raised to -2. Okay. Okay, enough. Next. Nivin.
Yes, sir.
Yeah. Shall we continue? So which operation we have to do first? In this squaring. Okay, just give the answer. M raised to
M0.
0. L.
L2.
Okay. T.
T raised to -2.
-2. Then here.
Same. M0.
Okay, fine. Here.
M0.
Okay, that's enough. Okay. Then, which operation we have to solve first? Only one is remaining. So what happened? If you solve this one, M0, L raised to, L raised to 2. See, I told you to add the power when these two are in multiplying.
Sir,
What? Yeah, L square is okay. See, okay, so L raised to?
2.
Wait. One more time is missing. We didn't write S.
Yes, S not
Okay, wait. Okay, just erase this one. We have to write S also. S means M raised to 0, L raised to 1, T raised to 0. Okay, we can add. So M raised to 0, L raised to 1, T raised to minus 2 here equal to M raised to 0, L raised to 1, T raised to minus 2 plus M raised to here what will obtain?
M raised to 0.
0, L raised to
L raised to 2.
1, T raised to
T raised to
minus 2. Maria Roy. Maria Roy, are you there? Okay, is there any mistake you can see here? Is there any mistakes are there?
Yes.
Yeah, what's the mistake? No mistakes, everything is correct. What one?
No mistakes. I think so.
I think so. I don't want anything so. Say it correct. Is there any mistakes are there? See, if your answer is wrong, you will get imposition.
I took the square.
Okay, so what's the mistake? Any mistakes are there? No mistakes. Maria Roy?
Yes, sir.
No mistakes are there. Fixed. Just to fix one. Either you say no mistakes. Okay, I think Maria Sandra Maria. Who's there? Maria Sandra, I think.
Yes, sir.
Yeah. Okay, Maria Sandra, just to go through this end portion. Is there any mistakes are there?
The B square
What? B square?
and then L raised to 0,
Okay.
L raised to 2,
L raised to 2. How you obtain L raised to 2?
L raised to 1 square of equal to
Okay, so here or here?
here,
Okay, so both sides I have to correct. Okay, then any mistakes here?
So I got L raised to 2,
L raised to 2. How you obtain L raised to 2?
then L raised to 1 into L raised to 1.
Yeah, correct. See students, it's L raised to 1 plus L raised to 1, L raised to 2. Okay, now get back to Maria Roy. Maria Roy?
I got like this system, sir.
Oh, okay. So next one I think more students. Okay, and natural backendalo. Nivin. Okay. Nivin? So now it's correct. Anything to change? How do you feel?
No, nothing.
Nothing. Okay, just to conclude, Nivin. Just to complete this. No. Just we have to add this also. S square T raised to minus 2. So equal to M raised to L raised to. Okay, T raised to. Okay, so we obtain as LHS equal to RHS. So equation is dimensionally correct. Okay, so students have one more equation to solve. So we just study the basic equation and few equation. Okay, we proved that till now these equations are dimensionally correct. Okay, so So I think you're familiar with other equations too. See, any trigonometric terms, constants, numbers, okay, especially numbers and constants, you can able to ignore. Like G, capital G, universal gravitation constant. It's a constant. So numbers and constants you can ignore, just ignore them. Okay, numbers and constants you can ignore. Carry on with the other terms. Okay, so students, I'm going to erase the board. Now you have one more equation to solve. That is, I think you are familiar with this equation. F equal to G into M1 M2 divided by R square or D square. I think you have studied with D square, D or R, whatever may be. Mahadev, do you familiar with the equation? Mahadev, where you study this equation? Okay, not acceleration due to gravity. It's equation for universal law of gravitation. Correct. Universal law of gravitation, not gravity. Okay, Mahadev. Mahadev?
Yes, sir.
Whose law?
Universal law.
No. Which scientist discovered this law?
I don't know, sir.
Mahadev, famous scientist. Most of the gravitational concepts are related to that scientist. That much popular, like Mahadev. Popular like Mahadev. Don't know?
Newton.
Yeah, correct. Exactly. So, students, your work. This one. Okay. Just prove this equation is dimensionally correct or not. Give it time, consuming, but you have to solve it. Okay. Okay, Jerome. Jerome,
Yes, sir.
completed.
Yes.
What?
Yes.
Yes. Then what do you obtain? This equation is dimensionally correct or not?
Correct.
Incorrect. So equation is wrong. Am I right?
Yes.
Okay. What about this? Nivedita? What do you obtain? Nivedita? Nivedita, are you there? Yeah, what do you obtain? Final answer. The equation is dimensionally correct or not?
I didn't get it.
What?
I did not get.
What do you obtain? Could you complete the question?
No, sir.
Okay, where are you stuck? Not able to complete it.
Hello.
Yeah, just talk. Where are you stopped? What about?
About to complete.
Okay. Esther?
Yes, sir.
Yeah, what about you? Completed?
No.
No. So, what do you feel? Could you able to complete it?
No.
No. What happened?
Okay. I think the case is incorrect. Check. Not correct.
Okay. Then what about Devipriya? Devipriya?
Yes, sir.
Yeah, what happened? Do you complete it?
No.
Yeah, what happened?
Not getting.
Not getting. Where you stopped? Could-
One and one I don't getting.
Akash. Akash. Ashish.
Correct.
Yeah, what about you? So question is dimensionally correct or not?
Incorrect.
Incorrect.
Yes.
Are you sure?
Yes.
Okay. What about Sandra Maria? Or Maria Sandra? Okay, Maria Sandra.
Yes, sir.
Yeah, what's your opinion? So question is dimensionally correct or not?
Not correct.
No, it's a wrong question.
I got not correct.
Okay, so all of you saying that Newton is wrong.
That I don't know.
So you are all saying that the Newton's equation is wrong. The equation is wrong. You are not able to prove that equation is dimensionally correct. So this equation is wrong. Am I right?
I don't know.
I don't know. Okay, students, listen. See, actually, you may obtain that. It's okay. Whatever you done is correct. You don't obtain this equation as dimensionally correct. But actually, equation is correct because what's the difference is that here, this one, G. Normally, for equation, constants are there. Normally, we will remove that equation, remove that term. But here, the G we can ignore. Normally, we can ignore the constants. If it's a number, just a number. Normally, we can ignore a constant if the constant is just a number. But if the constant have units, then you can't able to ignore. Okay, so that's a mistake we make here. We ignored G, but actually this constant have a unit. You know what's the unit of G? You can find out. See, take d square here. Okay, so just listen here. Take d square here. So f into d square by m1, m2 is G. So Newton. So just stating Newton meter square. Here kilogram into kilogram. So kilogram square. Okay, if you split this Newton, kilogram, meter per second square into meter divided by this kilogram square, cancel. So meter square, kilogram inverse, second raised to -2. Like that, a unit is there for G. Okay, so the mistake you made is that we didn't consider the unit of G. If there is just a number, constant number only, means you can ignore. Just 20, 100, 10,000. If any numbers are there, you can just ignore the number. But if the constant carrying a unit, you can't able to ignore it. Okay, so students, nothing is written here, just forget everything. So your job is, first you have to find the unit of G. First you have to find the unit of G, then substitute the value of G, find the dimensional formula, then prove it. Okay, so then check whether the equation is dimensionally correct or not. First you find the unit of G, universal gravitational constant. Then find its dimensional formula of G, then substitute it, then try again. Okay, I think it's almost time. Okay, we don't have time to complete. So all the students complete this one and send notes. Okay, I think few students, I didn't get the notes for few students last class. I think last class always at the beginning I'll read the list of students should put in submit your notes. Okay, so send notes without any delay. Okay, complete this one, then send your notes. Okay, So see you next class. Thank you.